We're here to talk today a little bit about El Nino. Just to start off with, can you explain to the viewers at home in a way that they may be able to understand what exactly El Nino is?
So it's called the El Nino Southern Oscillation, and all it is a alternating warming and cooling of the ocean temperatures in the eastern tropical Pacific near the equator. Now it sounds a little complicated. It is kind of complicated, but that's all it is. So when the eastern and central tropical Pacific water temperatures are above average for a prolonged period of time, we call that an El Nino. When they're below average for a prolonged period of time, we call that a La Nina. And when they're about average for a long period of time, we call that neutral.
Great. So why is El Nino important for our weather here in the valley?
So when we get into El Nino with the warming of those waters, a couple of things happen. If the atmospheric pattern behind that, the background pattern, is conducive to fast-moving flow, meaning jet stream energy, then El Nino will help inject tropical moisture into it from fall, winter into spring, and it can produce impressive amounts of rainfall from west to east. Now, if that jet stream sinks far enough south, it can affect places from California to Texas to Florida. If it stays a little farther north, it may bypass parts of Texas and Florida, but because California is a bit farther north in latitude than we are, it can hit them with good amounts of rainfall. And we've seen that this winter. There's been locations in California that have had near record rainfall from system after system after system. And El Nino is helping to inject that tropical moisture into it because of those warmer waters.
Great. So I know NOAA has put out an El Nino Advisory recently. What does that mean, and what can we expect going forward because of that?
So all the El Nino Advisory means is that we are confident that an El Nino will occur. Now, what is an El Nino defined? An El Nino defined isn't just the fact that the waters are warm. Remember I said prolonged period. A prolonged period means 5 successive 3-month periods. January, February, March, March, April, May, February, March, April, May, consecutive, where their index value is in the El Nino range. So the advisory says that there's a high confidence that we're going to have that 5 consecutive 3-month period that will have that value reaching El Nino. We've already reached 3 of them to end the year, and now getting into the beginning of this year, we expect to see number 4 come up at the end of February, and then the forecast is for that 5th one, that 5th 3-month period to occur between January and March, which will give you the 5 you need to consider it an El Nino.
So, digging into a little bit more of the meteorology of it, we know that El Nino doesn't just impact us here in Texas, but isn't it a global type of an issue?
It can. I mean, what happens in the eastern tropical Pacific can impact what happens across the globe, starting with the United States, but then traversing across the world. So we kind of look at a backside of it, where the waters tend to be warmer in the eastern Pacific, they might be cooler in the western Pacific. And where they're cooler in the western tropical Pacific, that would tend to reduce rainfall and increase the probability of drought. And that can then can extend backward into places like India and possibly even into the Middle East. And then we can look forward and sometimes extrapolate El Nino events into Europe. So eventually it kind of peters out on both sides, but where there's warm, there's equal and opposite cool, not necessarily equal, but opposite cool of the waters, and that can change the way the atmosphere can or cannot produce rainfall, thunderstorms, energy, what have you, versus lack of rainfall, lack of energy, lack of thunderstorms.
Right. So if we're expecting more of that drought-like condition to be across the Pacific over in Eastern Asia, would that mean that people here in the valley should expect a wetter spring and summer coming up? What do you say about that?
So in the wintertime, when we have the more active jet streams, it's a matter of how far south they go. And what we're finding this year is that the predominant jet stream, is called mid-latitude jet, is being infused by this tropical moisture, creating the rainfall, the landslides, what have you, in California, helping to create the heavy rainfall in parts of Texas, mainly east and northern Texas, as well as some of the heavy rain events we've seen in places like Tennessee and Kentucky and Mississippi, Alabama recently. The jet stream's a bit farther north, though, for the valley to tap into. In other words, we're not tapping the tropics directly. And if that were to happen during the winter, we'd have much more rainfall than we've had. In fact, we're running below average so far. The question that needs to be answered still is, what will March, April, and May bring? Will there be a sagging of the jet stream where we can pick up that tropical moisture and send it over the valley? Or will it continue to migrate farther north, as it typically does as the sun gets stronger, and give us even lesser chances of significant rainfall on a routine basis? So the thinking right now is there's equal chances of above or below average rainfall. The lean would be to continue the below average, because there's been no sign since January all the way into the end of February that the tropical or subtropical jet stream is going to connect in with this mid-latitude debt. It's just not existing. So the moisture is being fed into the Pacific Ocean and then moving across the U.S. Well north of where the Rio Grande Valley's latitude is. Now, that does not mean we won't see the possibility of a rogue event create thunderstorm clusters that could produce everything from flooding rain to big lightning to hail and strong winds. We can't rule that out because the atmosphere is pretty active not too far to the north. So it's not as if there's a big suppressing high pressure ridge keeping us dry for days and days and days on end. We're seeing it now. These fronts are coming through. They're bringing a little bit of rain and drizzle with them. It's possible that it tags up with some energy during March, April, and May. We'd have to watch for that. So the main thinking for the spring is it should continue to be above average temperatures, because in general that jet stream lifts to the north and it brings more heat from the Mexican plateau downsloping air, which warms us up even more than we've seen for this winter, which has been slightly above average. But there could be buckles in the pattern where those buckles bring a front, and along that front, whether it's dry or cold or both, now that we're getting into the more unstable atmosphere season, there could be some significant thunderstorm events. So prepare for that possibility, but also be ready that the potential for drought to worsen, especially over the mid and upper valley, is equally opportunistic for this spring.
That's good to know. So I know when we're talking about El Nino, we're talking about tropical energy, we're talking about tropical moisture. Could this have an impact on the upcoming hurricane season and what we could see here in the Gulf of Mexico?
So the forecast for this El Nino, which is in the weak to possibly moderate phase, is not going really strong, is that it will go back to the neutral phase of El Nino Southern Oscillation, which basically means you take it out of the mix for your tropical cyclone, storms and hurricanes probabilities, and you look at other factors. The Atlantic Ocean, how warm or cool is it? The Gulf of Mexico, how warm or cool is it? What are the other atmospheric connections that could create a busier or a quieter season? That's probably what we're looking at. We're going to probably move El Nino out of the predictive part of the hurricane season and look at other factors for this year. I'm going to say this, though, and I say this every year. It does not matter whether you're in an El Nino, a La Nina, or a La Nada. In other words, nothing at all. The Gulf of Mexico can spawn hurricanes in any of those type of situations because it's predicated on depth of water temperatures, warmth of water temperatures, and upper level disturbances, tropical disturbances that can just fire up almost out of nowhere. And if we look back at Hurricane Harvey, for example, that was an Atlantic wave that came through as a tropical storm in the Caribbean, and then it weakened dramatically and it festered for a few days. And the next thing we know, the atmospheric pattern, the steering pattern, turned it into Texas, and it felt the warm water, the low wind shear, it had moisture with it, and next thing we know, we have a Category 4 storm knocking on Category 5, about to run into Rockport, Texas. Look back at 1989, Hurricane Brett formed out of the southwestern Gulf. Maybe it was a seed from a prior wave in the Atlantic, but it reformed over the southwestern Gulf, and next thing we know, Category 4 storm not too far away from the Rio Grande Valley, fortunately missed the area. And most importantly is maybe 1983's Hurricane Alicia. Now, Alicia did not hit the valley, it hit Houston. But in that year, because there had been an El Nino that had been moderate to strong all the way into spring, early summer, it set the stage for high wind shear, which is an enemy of hurricanes, over the western Atlantic Ocean. It also, there was dry air in the atmosphere. There were other factors too. There were only 4 named storms that entire season for the entire Atlantic Basin. The Atlantic Basin's a big place. It's the Atlantic Ocean all the way up to southeast Canada, all the way over to Portugal and Spain. all the way off to the coast of Africa. You have the entire Caribbean Sea, you have the entire Gulf of Mexico. 4 named cyclones. That's it. One of those named cyclones was named Alicia. It formed from an old front, a cluster of thunderstorms. It got hung up in the central Gulf, and then it fed off of that very warm water that we have in the Gulf of Mexico just about every summer. And the atmospheric steering pattern began to reduce the wind shear and allow it to push westward. It could have hit the valley at one point, but instead it moved a little farther north, and $9 billion in damage later, Alicia was the storm of record for the Houston-Galveston area for its combination of wind surge and some rainfall until Ike in 2008. And it occurred at the tail of a moderate to strong El Nino. So it doesn't matter if you have an El Nino, La Nina, or La Nada, that one festering ball of moisture with low wind shear and warm water temperatures can get going and make the season memorable no matter what happens elsewhere across the basin. And for Houston and Galveston, they could care less in 1983 that there were only 3 other storms out there, 3 other cyclones. They had $9 billion in damage, 2012 damage. That became the storm of record in modern times until Ike came around. So there's something that says that we couldn't have that storm in any given year, which is why we always say, even now in March, because the season's forecast or the season hasn't come, now's the time to start thinking about your hurricane season preparedness, because it only takes one.
Right, exactly. And that's part of the reason why we're here today to talk about that a little bit. So I guess my last question about El Nino is, how do you, here in Brownsville, how do forecasters around the country track El Nino and know that it's going to be coming or that it is waning?
So we track it as everyone else does. We look at the information that's provided from satellite data, from our experts at the Climate Prediction Center, from other research institutions that do a lot of heavy tracking of those sea surface temperatures in the Pacific, what's showing up on satellite in terms of thunderstorm activity out there in the eastern tropical Pacific, and then the duration, how long is it lasting and how intense is it getting through the index patterns we look at, waves of energy that move across the tropics from west to east across the equatorial region. We follow along with what the experts do, who live, breathe, and eat El Nino, if you will, and then we go from there. They also help us with the broad base of the forecast. In some years, when you tie the El Nino together, or the El Nino Southern Oscillation together with these background atmospheric connections in terms of how the air is flowing from the pole to the equator and vice versa, unrelated but connected. El Nino is just one. El Nino Southern Oscillation, just one factor that can go into making that forecast. One year there was a forecast made for winter, given a moderate to strong El Nino. I believe it was 2015, 2016, where we forecast a 64% probability, a 60+% probability of above average precipitation in South Texas, which meant that there was a less than 10% probability of below average precipitation, which means if you're an agricultural interest, somebody who's planting crops, you might be happy with that forecast because you don't have to worry about spring irrigation as much. If you're an event planner, such as Chado Days or Sombrero Fest, or any outdoor activity that happens here in the winter and early spring, because it's usually warm and somewhat sunny, or at least not super wet, you'd be, oh no, we might get rained on, we might want to take out an insurance policy for that event. Well, guess what happened? The less than 10% probability of below average precipitation is the answer. That's what happened that year, because other atmospheric factors were much more dominant in terms of how the winter worked out to change that forecast from a forecast that people could act on to prepare for rain into a busted forecast where it didn't work out. Doesn't mean people are unhappy they had events planned and they were able to do them, but for farmers and for agricultural interests, maybe they needed to consider irrigation that spring, where they might not have thought about it based on the forecast in the fall with an El Nino in place. So we have to caution everybody that there are probabilities, that there is some uncertainty even in those probabilities, and we saw that in 2015-16, where the forecast was for confidently above average precipitation, and it didn't happen. This year the forecast was for a little less confidence in above average precipitation. For the winter, it didn't happen. We actually ended up a little bit below average. Not a lot, but a little bit. And so in a sense, that probabilistic forecast saying there's a 40 to 45% probability of above and only a 23% probability of below. Looks like that 23%, when we look at all the numbers for December through February, was the one that was the answer. So it's still a reasonable probability. It still means you have a 2 in 10 or 3 in 10 chance that you'll get drier than average. It just shows that there's more things going on in the atmosphere than El Nino alone. And to focus on that alone is kind of a fool's errand. And it's the same for the tropical season. If you focus on a strong El Nino forecast for summer, and we don't have that, but if you did and said, oh, it's going to be a quiet year, we're only expecting 7 to 10 named cyclones, of which 2 to 4 will be hurricanes and 0 to 1 will be major, category 3 or greater. 1983, Hurricane Alicia, category 3, right? That was the 0 to 1. And that was not too far away from the valleys. So we always need to be on guard and better safe than sorry. Prepare as if the year coming up, whatever year that is going to be our year, regardless of what that forecast is, or regardless of where the phase of El Nino Southern Oscillation is.
Fantastic. So is there anything else that you want to add about El Nino and how it could impact the Rio Grande Valley that we may not have covered?
The only other thing I would add is, because of the spring uncertainty with the continuation of active energy just to our north, meaning we could see some more fronts, such as the one we're going to see next week. As we get later into the season, with the atmosphere percolating, getting warmer, getting a little bit more humid than it would be, say, in January, February, the opportunity for dangerous thunderstorms that can produce hail, wind, and flooding rain may go up a little bit. So even if the forecast is for equal chances of above, below, or average rainfall, and average rainfall through this period of March through May is pretty low. It's generally, I think, 3 to 5 inches across the valley when you add the 3 months together, so it's not a lot of rainfall. But all it takes is one thunderstorm system that forms along a front, we call it a frontal boundary or frontal system, if you will, that can produce 2, 4, 6 inches of rain in one shot. Think about the McAllen hailstorm. Despite the fact that even though there was, we remember it for penny-sized, quarter-sized, ping-pong ball-sized hail that was falling in mass quantities, driven by 74-mile-per-hour winds for 45 minutes, were 4 to 6 inches of rain on that event, March 29th. That rainfall on that event alone was the entire spring season's rainfall for the city of McAllen in one thunderstorm complex that lasted about 4 hours. So the potential exists for that. I'd say in any year it does, but when you have a fast-moving jet stream where you have frequent energy impulses that can produce those thunderstorms, if that were to continue into April and May and even parts of March, then we have to be aware that that number could be a bit higher than on average. And if those storms come with those elements I mentioned before, people need to be prepared to take action, imminently. But if they're prepared now to know where to go, where to put their families into a safe place, where to move their vehicles, where to be on roads that typically flood, how to get away from them quickly, those are things that people can do now as we enter into our spring preparedness season, to be ready for that potential, given the fact that these fast-moving systems as we move into the spring, if they continue, could produce more opportunity for inclement weather and potentially dangerous weather.
Fantastic, Barry. Thank you for your time.